Hello, it's Scott Manley here. On Friday morning, Indian Space Research Organisation launched Chandrayaan 3 on its mission to the moon. And this was a big event. The live stream on YouTube had like 8 million people watching it. There is a huge amount of interest, national pride, just straight up excitement for this mission, which will hopefully land a spacecraft on the moon. And this is, of course, a follow-up to Chandrayaan 2, which unfortunately failed to complete its landing on the moon and crashed for, well, complicated reasons which have never quite been released to the public. The launch vehicle was the LVM-3, formerly known as the Geostationary Launch Vehicle Mark III. This is the largest launch vehicle that India has. It has two large 3-segment solid rocket motors called the S-200s. Those both light at T0. The core stage is powered by a pair of Vikas engines burning UDMH and dinitrogen tetroxide, and those don't actually light until about 2 minutes into flight, just before the solid rocket motors separate. Finally, there is a third stage, which is fully cryogenic, using hydrogen and oxygen. This, of course, is great for getting those high-performance boosts into geostationary orbit, and that's what was used to carry the spacecraft into its initial transfer orbit, which is very similar in terms of altitude to a geostationary transfer orbit. But in this case, it was inclined at a higher inclination because it's going to the moon rather than GTO. So once in that orbit, the Chandrayaan spacecraft was deployed. And to be clear, this is a multi-component spacecraft because this is a very complicated mission. But yet, it was deployed into this orbit, and now over the next few weeks, it's going to make a series of maneuver to raise its orbit up towards the moon. It will eventually get captured by the lunar sphere of influence, or the lunar gravity, and from there it will lower itself down into a low lunar orbit, and finally it will deploy the Vikram lander, which will hopefully perform a soft, controlled descent to the lunar surface, enabling its instruments to study the surface of the moon, and also the deployment of a small rover, which should be able to perform its own independent study for up to a couple of weeks until the sun finally sets, and after that the vehicles will be without power and they will get very cold and they will probably not survive the lunar night, but it would be a nice bonus if they did. So if this is successful, it would make India the 4th country to successfully soft land on the surface of the moon. It wouldn't be the first time they landed on the moon, because the very first Chandrayaan spacecraft went into lunar orbit and performed a bunch of remote sensing, but it also included an impact probe, a probe which was going to be dropped. This would descend towards the surface, and I'm sorry to say, but the real thing hit a little bit harder and probably isn't in as few pieces as this animation would suggest. I mean, that's what the laws of physics tells us. And then, of course, in 2019, there was Chandrayaan 2. This was a much more complicated mission. It actually included an orbiter, which had an onboard orbital high-resolution camera, which has been able to survey the lunar surface at the highest resolution of any camera in lunar orbit. And this has been a pretty successful mission over the last few years, but it also included the lander. And this lander was supposed to be the highlight of the mission. They had a lot of important people at the launch center during this landing, and it performed pretty well during the early steps of the descent. Unfortunately, when the fine braking phase began, the vehicles somehow ended up upside down. At least according to the telemetry. We're not really clear if this was the actual attitude, but it seems like it's pretty likely. The vehicle ended up falling towards the surface and impacted at speeds of about an order of 100 meters per second or so. But even with that knowledge, there were a lot of people who really wanted it to survive, for reasons of national pride. It's totally understandable. And they hung on to hope that it had somehow made it to the surface and it was just like on its side. Its antenna wasn't pointing at the Earth. But yeah, eventually it was found that there was a big debris field where it was supposed to be. And unfortunately, we never got the proper full report about what actually happened that resulted in this crash. We had a few statements to the press about things perhaps overperforming, but we never got a complete and unambiguous explanation for why the spacecraft had performed so well early on and then decided to lose attitude control right at the end. But now with Chandrayaan 3 on the way, we got a few more clues in press statements recently. As I understand it now, what happened was that during the early part of the descent, they were decelerating slightly higher than normal, and this meant that there was an error slowly building up as to where the impact point would be. And when it finally came out of this course-breaking phase and decided to start trimming its trajectory, it realized that it was way too short for its target, and it wasn't sure how to actually make it to that target, and ended up having a bunch of conflicting requirements because it wanted to make that very small target, but it couldn't make that very small target, and then some other issues got in the way. I would love to see the complete report so I could break this down for you. But I guess the most important thing is that the engineers and scientists that have been working on Chandrayaan 3 have been privy to the information and have made changes. They've understood what went wrong in the software. One thing that they're doing is they are expanding the range over which the lander is allowed to land. So if it does end up coming up short, it can be a little more cool with it. They've uncapped some of the rotation limits, which also apparently contributed. It's not clear why. But there have been physical changes to the lander hardware. The most obvious thing is that it now only has 4 engines. It no longer has a single central engine. Now, the original Chandrayaan would land on that single central engine, but now it has 4. It actually needs 2 of them to complete the landing because of the increased mass, the larger propellant tank. And that larger tank is really obvious when you put these 2 spacecraft side by side. So presumably that's going to allow for some extra sensors. I know that there's going to be a laser Doppler velocity sensor that's going to be used for landing. I also understand they're going to be carrying more solar cells for unusual attitudes they might end up with on the surface. The landing legs are going to be a whole lot stronger. You can see the difference in the thickness of the landing pads between these 2 spacecraft, so that if it does come down a bit hard, it has a better chance of surviving. And hopefully around August 23rd, we should find out if all these changes have worked when it is going to make its landing attempt. Once again, the spacecraft is targeting a landing site that is far south, close to the lunar south pole. I think the latitude is about 73 degrees south. In terms of instruments, the lander carries a seismometer, a thermal probe, and a plasma measuring system. It also carries a passive lunar retroreflector array, which has been provided by NASA. This is a classic passive instrument where you shoot a laser at this target on the moon and it reflects you back, and you get very accurate distance measurements, which allows you to do some science. But the real reason this is here, of course, is because it then makes it a partnership with NASA, which means the NASA's Deep Space Network can be used to help communicate with the spacecraft in deep space. The rover carries a pair of instruments which are designed to examine rocks and minerals close up. You've got an alpha particle X-ray spectrometer where you basically hit a target with alpha particles and it gives off X-rays, and you can figure out what elements are in there. And there's a laser-induced breakdown spectroscope where you basically hit a target with lasers and it vaporizes it, and the color of light that comes off lets you understand the chemical makeup of the materials again. I'm sure that once it gets there, the spacecraft will generate useful and interesting science, but I think the thing that really sort of excited me has been just watching the population of India. Like, all these people come out and express such support, like turning up to watch this launch in droves. It just made me excited for it. I love this photo of a sand sculpture that somebody put together in tribute to the launch. Although I'm confused as to why the official ISRO account decided to post a bunch of pictures from the wrong launch. The lettering on the boosters is in the wrong place, and if you look at the core of the rocket, there is a flag that doesn't exist on the photographs. Only one of the 4 photos in this post is actually of the correct rocket. And by the way, if you think the rocket looks a little short and fat...
So, once again, the fat boy has done its job.
Yeah, I like the fact that their own engineers called it the Fat Boy. If you watch the full live stream, they actually have a great section showing how they assemble the rocket on the pad. They use these 2 large 3-segment solid rocket motors, and it's great because you can see them putting the sections together with the O-rings and the bolts, and you can see the channel down the middle. India is heavily invested in solid rocket motors, and they build some of the largest solid rocket motors in the world. I also like the fact that they showed the installation of the igniter at the very front of the rocket. This is a pyrotechnic device that sits inside that channel, and when they light the engines, that's the first thing that lights. It blows hot gas down that channel in the middle, lighting the rest of the solid rocket motor. So the GSLV-3, the LVM-3 is what's going to be used to launch India's Gaganyaan, which is going to be their crew spacecraft. And I don't know when that's likely to fly, but when it does, it'll be a short, independent orbital, mission. This is going to be distinct from India's recent agreement with the USA to let Indian astronauts fly to the International Space Station. That will almost certainly be on Dragon or maybe Starliner. But for now, the flagship of India's spaceflight program is Chandrayaan-3. On its way to the moon, it's already made successful orbit-raising burns, and we expect to be in orbit in a few weeks, and I believe the current date for the landing is expected to be August 23rd, and I will be paying attention and hoping for the best. I'm Scott Manley. Fly safe.